So next we have Taber MacCallum. And Taber is, of course, one of the original Biospherians, of the original 8 that were in the biosphere for 2 years. And Taber and Jane are founders of Space Perspective, which is an organization that we're bringing, I'll let Taber introduce all of it, but bringing people to the very edge of space in very sophisticated, beautiful high altitude balloon rides. So Taber's going to tell us a little bit about the test module, which he designed and built. So we're excited to have that history of the test module, which will become the greenhouse for SAM. So Taber, if you're ready, it's on to you.
Thank you. I'm going to share my screen here. Can everyone see a beautiful picture of the test module?
Yes, we can.
Mm-hmm.
Awesome. So I'm going to give you a little bit of history. I certainly wasn't, I wouldn't say I designed the test module. There was a lot of people involved in contractors, but I was responsible for it in its construction and operation. The test module had a lot of roles, but let me first describe sort of what it was, it is still. It was a structural and sealing test bed. So the superstructure of Biosphere 2 was being tested, how we seal the glass, how we build that structure to cover the top of Biosphere 2, and then also the stainless steel flooring and foundation of Biosphere 2 was being tested. We also were trying to figure out how we were going to take up the expansion and contraction of the air volume inside that occurs with barometric pressure changes, temperature and humidity changes, and the like, without having to take that as a pressure change in the biosphere. And so we built this variable volume chamber. It was sort of misnomered the lung, and we had that system running as well. So it really worked quite well as an initial structural test system. This picture in the background you see, this is the first attempt at a glass and sealing system, and it really sort of exemplifies an iterative approach to design. So we had the structure inside that you see, the space frame structure, and then over the top of that we had a sort of a welded frame system for the glass. And for many reasons, this turned out to be problematic, but one of the main reasons it turns out was we had 2 seals, an inner seal and an outer backup seal, and we thought, well, 2 seals are better than 1. But what it turned out was that it was impossible to find the hole, because if you had 2 holes, they could be a long way apart, and you couldn't on the outside find out where the inside hole was, and vice versa. So actually the more complex system turned out to not be the right answer for us. But in whole, I think what I want to convey is that it was the first time we had sort of a piece of hardware to begin working with. After some iterations, we got to a final structure. You can see in the background of this picture, the top center, something that looks like the test module. And that was that first iteration you saw. We literally took the entire top off the test module. It became a gift shop, and rebuilt the test module with a sealing system almost identical to what you see at Biosphere 2 now. Part of what made this system work was that we were able to take up expansion and contraction at every node of the glass and steel structure, so that the thermal expansion and contraction that the Biosphere 2 has, which amounts to actually a little over an inch at the ends, is taken up sort of evenly through a more fluid structure. So we really got to test how we implement, how we seal, what the processes are, how we test for seal integrity, all of that. So, and then we also extensively tested the lungs. So now we've got structures down, and then the thought was, well, let's see what we can do with the test module for understanding closed system ecology. So it's worth mentioning that this flask, picture of this flask, was the state of the art in closed ecosystem science at the time. Man named Professor Claire Folsom at the University of Hawaii was extensively testing these little ecosystems with things like labeled carbon tracers and the like, and was really getting an understanding of how a microbial system worked. And we were going to make this big jump to a system with higher organisms and ultimately people. So we began putting plants and animals inside the test module, and then human experiments began in 1988. It both helped us a lot and in many ways gave us a false sense of where we were in sort of designing these systems and making them work. And so I'll get into a little bit of that. But along with sort of the technical side of a testing and iteration, we obviously got now some media, and that was helpful in that it helped give confidence to those who were funding and sort of bring the project out into the open and show that we were making technical progress. But of course, that level of exposure also was, I think, difficult for us to deal with at the time in terms of our sort of administrative management way of dealing with that. But it did exercise sort of all aspects of the organization, from PR through financing through technical achievements. So that's me in a white suit squatting there in front of the test module trying to make a monitor work, I'm sure. It was an excellent source of analytical samples. We really didn't know what the matrix would be. That's the water and air mix of compounds that we'd be trying to analyze. And we actually did a couple of iterations on the design of the Biosphere 2 analytical lab using the test module as the sample source. And so for how we did remote sensing of samples, how we transported and took samples, we actually ran sample lines from the test module back to the laboratory and back. So many iterations of how we would understand and monitor Biosphere 2 were developed in the test module. And to that regard, it was really critical for us. I think it was, some of the downsides was we thought that the model, how we modeled solar transmissivity through the structure we overestimated how much light would get into Biosphere 2, which is something Biosphere 2 is paying for even now. Because we looked at how much light went through this structure and said, well, that must represent how much light's getting into Biosphere 2, without looking at the geometry of how Biosphere 2 is set up, especially in the agriculture with the barrel vaults coming into places in the middle. So I think sort of the lesson of history of Biosphere 2 with regard to the test module is, and it's a general lesson, be careful how you use data from an early iteration and extrapolate that to the full size system. And that's sort of one example of that. It did serve as a reasonable test bed for subsystems like waste recycling. We had our first, it was a NASA Stennis developed system by Billy Wolverton for doing wetlands waste recycling system. We had one of his systems inside, and we were really able to both look at off-gassing and performance and cycle times. And it really allowed us to prove out subsystems. And it was also then begun to look at as a way of anchoring a carbon cycle model and due mostly to politics and a crude initial attempt at modeling. That effort was killed. And I think it's an interesting lesson because I believe that had the carbon cycle modeling been allowed to continue, it could have, excuse me, I think I just, it could have elucidated some of the issues we had in Biosphere 2. So it's, in terms of testing, and I'm sort of trying to get into lessons learned as we go through here, as you do an iteration or a design cycle, so careful how you use that data and what conclusions you make from it. We had a very small amount of soil and small amount of sort of digestible carbon in the test modules. So we actually saw what looked like a system that was more carbon starved than energy starved. And so I believe we would have, especially if we'd done a larger test module, been able to apply a lot of lessons from it in the design of Biosphere 2. But of course, we were on this crazy schedule where the design of Biosphere 2 was being locked down at the same time as we're doing this testing. It also didn't have appropriate representation of materials in proportion, which also led to bad assumptions about carbon cycling. So I think the most glaring example is that we didn't have any concrete inside. So we didn't see the absorption of carbon dioxide into the concrete. It may have been an early signal that this was going to be an issue. So it sort of gave us a false positive that things were going well without really sort of thinking through the proportionality of what we were doing. Interestingly, we later used test module data to generate a hypothesis about ecosystem stability that actually led to a patent in how closed ecosystems work. And those systems were used on the Russian Mir Space Station, Space Shuttle, International Space Station for long duration experiments with plants and animals in an aquatic system that was actually used to breed the first animals through a complete life cycle in space. And so I guess the interesting thing is that the data was there, and essentially what you see when you look at that early test module data is that the system was limited by available carbon dioxide, not available energy. And that, it's a long story, but in essence, that creates a feedback loop in the system that really stabilizes it. In many respects, Earth some decades ago was also carbon limited in many respects. So there's some interesting parallels here in how in that data that was actually there for us if we had been able to really use it. I think the test module really is an iterative example of a test and development strategy that could have been leveraged a lot more, but I don't think that Biosphere 2 would have been as successful as it was without it. I think we, in hindsight, would have benefited from actually a series of increasing size test modules coupled with a rigorous modeling program. And even though, you have to remember that the 286 had just been invented, it really did, there was enough data there that really pretty simple, even sort of spreadsheet-based models would have elucidated a lot about that carbon cycling. The other thing Biosphere 2 did was really push the data acquisition side of this. When I built the test module, all the data was being recorded on chart recorders. I mean, literally, I had banks of chart recorders that with pens and paper going across that would record light levels and carbon dioxide levels and temperature and things like that. And a local Tucson company called Burr Brown invented this thing called a multiplexer, which could be attached to this blazing fast computer called a 286. It could record the voltage as a number in memory that could be then imported into a spreadsheet and saved on the hard disk, which really changed our ability to do monitoring and control using computers. It's one of the first examples of monitoring and control with computers that there is actually the Biosphere 2 test module. So it has a lot of great places in history, and I'm thrilled to see the kind of programs and progress that Kai and others are are planning for the test module. It's super exciting, and Jane and I are super supportive of this work going on, and it's great to see this happening. So I think I've got a couple of minutes, Kaya. I can wait to questions at the end, but that was my presentation.
Thank you, Taber. Fantastic. It's tempting, of course, to dive into questions now, but we're going to hold to our agenda and and keep the questions for the Q&A period that comes after 2 more speakers, if I remember correctly. So thank you so much. We have a lot to learn from your experience, and look forward to working with you and Jane in taking all of the data and all the knowledge and the experience that you have and applying it towards SAM as we move forward. So thank you very much. And did you have anything to say? You have a few more minutes. Do you have anything to say about space perspective? Do you want to tell us a little bit about what you're doing with that?
Sure. Space perspective is in many ways sort of an outgrowth of everything that Jane and I have done over the decades together, but really has its roots in Biosphere 2 and the test module. One of those pictures that I showed sort of back away from the test module, and there's a person inside, and it's an interesting example that we experienced of what Frank White called the overview effect, which is, you know, what astronauts see when they see the Earth from a distance and get that sense of the Earth as one, you know, interconnected system, one human family. And we actually had sort of a similar experience inside Biosphere 2 and actually with the test module originally. So what we're doing is developing a system for taking people to the edge of space, to 100,000 feet, under in a capsule that's pressurized under a very large stratospheric balloon. We have been working with ballooning for almost a decade now. We have the record for human flight under a balloon and skydiving from a balloon and the like. And we're now at Kennedy Space Center putting together a team to develop a way to take people as a space tourism offering to the edge of space, to have that experience of seeing the Earth in the context of space, which given everything that's happening on the planet right now, we think is a very important sort of message to send or lesson to give people. And so we just closed a funding round, and we're based here at Kennedy Space Center at NASA in Florida. And you can see sort of some renderings of what we're doing at thespaceperspective.com. And if you're so motivated, sign up for a ticket.
Excellent. Are you giving 50% discounts to everyone on the call today?
Oh, at least.
Excellent. Thank you again, Taber. Appreciate you joining us, and thanks for making the time for us.